All right, let's get into it. Today, we're tackling one of the absolute cornerstone practicals in your AQA GCSE titration. Now, I know it can seem a bit daunting, but by the end of this, you're going to have the method, the maths, and the confidence to absolutely nail it.
So here's how we're going to break it down. We'll kick things off with the big ideas behind titration, the why. Then we'll walk through the methods step by step. After that, we'll crunch the numbers, sharpen up those exam skills, and finish with a super quick recap. Sound good? Okay, first things first. Before we even think about picking up a burette, we need to get our heads around the fundamental chemistry that makes this whole thing work.
So, this is the problem we're trying to solve. Imagine you've got a bottle of acid, but you have no idea how strong it is. Titration is basically the chemical detective work that lets us find that exact concentration with some serious precision.
And the secret, it's all down to a reaction called neutralisation. Honestly, at its heart, it's a beautifully simple reaction. You've got hydrogen ions from the acid meeting hydroxide ions from the alkali, and what do they make? Just plain old neutral water. The whole trick is that we can measure exactly how much alkali it takes to perfectly neutralize our acid, and that's what lets us work backwards. But how do we know our result is actually reliable and not just a one-off fluke? Well, this is where good science comes in. We repeat the experiment until we get what are called concordant titres. All that means is that we have results that are super close to each other. We're talking within 0.10 centimeters cubed. This proves our technique is consistent and our measurements are precise. Right, that's enough theory. Let's head over to the lab bench and get our hands dirty. Well, figuratively speaking. We'll go through the method step by step.
First up, our kit. You're going to be using some pretty specialized equipment here, and every single piece has its purpose. The pipette and burette, those are our high-precision measuring tools. The conical flask is shaped that way to stop you splashing everywhere when you swirl. And that simple white tile, it's there to give you a perfect clean background so you can spot that color change the instant it happens.
Preparation is everything here. You have to rinse the pipette with the alkali and the burette with the acid. Why? Well, if you just used water, you'd slightly dilute your solutions, and boom, your results are inaccurate before you've even started. Then you measure out your alkali, fill up the burette, and, this is important, make sure you get rid of that little air bubble at the bottom of the tap.
Now, your first go is what we call a rough titration. Think of it as a practice run. You're not aiming for perfection here. You just add the acid pretty quickly while swirling to get a ballpark figure for the endpoint. It tells you roughly where you need to stop so you know exactly when to slow down for the real attempts.
Okay, now for the main event, the accurate titres. You do it all again, but this time, as you get near that rough volume, you slow right down. You start adding the acid literally one drop at a time, swirling after every single one. You're on the hunt for that one final drop that makes the color change stick, and you keep doing this until you've got at least two results that are concordant.
And here's a perfect example of how you should lay out your results. See how the titre is the final volume minus the initial volume. It's not always starting from zero. And you can see straight away that titre 1 and titre 2 are concordant, both 24.05 centimeters cubed. The rough one is close, but we're going to ignore that for our final calculation.
Right then, you've done the hard work in the lab, you've got your reliable data. Now, let's turn those numbers into an actual answer. Don't worry, we'll go through it one bit at a time.
Step 1. Calculate your mean titre. And this is so important. You only use the concordant results. So, in our example, since both were 24.05 centimeters cubed, the mean is, well, 24.05 centimeters cubed. If they were slightly different, say 24.05 and 24.15, you just average those two.
Okay, here it is, the absolute golden rule of titration calculations. Before you do anything else, you must convert your volume from centimeters cubed into dms cubed. It's a really simple step, just divide by 1,000, but it is the #1 reason people lose marks. So our 24.05 centimeters cubed becomes 0.02405 dms cubed. Easy. With your volume in the right units, you can now use the magic formula that unlocks the whole calculation. Moles equals concentration times volume, or N equals C times V. You absolutely need to know this formula. Burn it into your brain.
So we use that formula in a simple three-step process. First, you calculate the moles for the solution where you already know the concentration. Easy. Second, you look at the big numbers in your balanced equation, the molar ratio, to find out the moles of your unknown substance. And third, you just rearrange the formula to find the concentration you're looking for. C equals N over V. Now, just sometimes they might ask for the answer in grams per decimeter cubed instead of moles. Don't panic if they do. All you have to do is work out the relative formula mass, the MR, of your substance and multiply it by the concentration in moles per decimeter cubed you just found. Job done.
Okay, knowing the method is one thing, but understanding why you're doing things and how to avoid silly mistakes, well, that's what gets you the top marks. Let's dig into some exam skills.
This is such a classic exam question. They love asking you not just what you used, but why you used it. So what's the big deal with pipettes and burettes? Why can't we just use a measuring cylinder?
It's all about using the right tool for the job. A pipette is designed to deliver one single, super accurate fixed volume, like our 25 cm cubed. A burette, on the other hand, is for delivering variable amounts, but with incredible precision and control, letting you add liquid drop by drop and read the volume accurately. Right, let's finish up by talking about the common pitfalls, the things that are so easy to get wrong. We've talked about rinsing with water, a big no-no. Forgetting the indicator, you'll be standing there all day waiting for a color change that never comes. Another one is misreading the burette. Make sure your eye is level with the bottom of that curve of the liquid, the meniscus, to avoid what's called parallax error. And of course, not swirling enough or just being too hasty and flying past the endpoint. Watch out for these.
Okay, deep breath. We've covered a lot. Let's just quickly boil it all down to the absolute must-knows. So here are the headline facts. 1. Titration finds an unknown concentration using neutralisation. 2. Your accurate results must be concordant. 3. Pipettes are for fixed, accurate volumes. Burettes are for variable, precise volumes. And 4. For the maths, N equals C times V is your best friend, and you must, I repeat, must always convert your volumes to dm cubed.
And just to leave you with something to think about, mastering titration is more than just one practical. It's a gateway skill. Now that you can precisely find a concentration, what else could you figure out? Could you determine the purity of a substance? Or maybe even the identity of a complete unknown? The possibilities are pretty cool.